Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm Ben McAllister, and this week we've been looking far and wide to find an answer to this cosmological conundrum from Sean.
Why is it that when you look directly at small faint stars, they disappear, but when you look at a point near them, you can see them again?
Good question, Sean. That one left me feeling a bit dim. It turns out the answer is all to do with a technique known as averted vision. And no, we aren't talking about what you're supposed to do if the Queen comes in the room. We're talking about a thing astronomers have been using for centuries to see distant objects. A few people on the Naked Scientists forum, like Colin 2B, Evan AU, and Flummoxed, all chimed in with helpful answers which, like a guiding star, pointed me in the right direction. And thanks to Alastair Frith for his very helpful answer via email, which helped shed some light on the subject. Naturally, I went and spoke to an astronomer, Dr. Matt Bothwell, to find out more.
So this is a really good question.
I thought so too. Thanks, Matt.
But the answer actually isn't anything to do with astronomy.
Oh.
It's all to do with how your eyes work. There are two kinds of cells in your eyes which do the job of detecting light. They're called rods and cones. Cones give us our colour vision, but they need very, very bright light to work. And they don't do very well at all in dim light or at night. The rods, on the other hand, are much more sensitive and can see very well in dim light. So it's rods that give us our night vision.
So it's all about those pesky rods and cones. The fact that cones don't work well in low light is exactly why, if you're looking around in the dark, it's very hard to see colour, and the world appears in grayscale. The colours of light that a given object gives off don't actually change based on the time of day. It's just that the rod cells in your eyes, which work well in darkness, can't really tell the difference between a red and a green.
Now, the issue that Sean noticed comes from the fact that these rods and cones aren't just distributed randomly across your retina. Right in the middle of your retina, the sweet spot of your retina, if you like, is a patch called the fovea, which contains loads and loads and loads of cones all closely packed together. And this is what gives you your sharp colour vision. When you're looking straight at something in really nice lighting conditions, the reason you can see it so sharply is all these cones packed together in your fovea.
So Matt, our astronomer cum, I guess, eye expert, is saying that the middle part of your eye is really good at seeing bright, colourful things, and not so great at seeing dim, dark things. You can do a little experiment here to see how this works for yourself. If you aren't actually colourblind, you can go ahead and Google colourblindness test and pull up one that looks appealing. If you look at it dead on, you should be able to see the different colours pretty clearly because of all of those wonderful cones in the middle part of your eye. But if you look at a point on your screen off to the side so that you see the test with your peripheral vision, even in good light, you'll probably find it much harder. If you are colourblind, well, I'm sorry, you're just going to have to take my word for it. Anyway, back to Sean's question. How does this relate to our ability to see dim objects, like stars?
The problem is that all these densely packed cones right in the middle of your retina are the ones that really struggle to see things in dim light. So when you look at something very small and very dim, like a star, all the light's going to be falling straight on the part of your eye that really struggles to see faint things. So what you have to do, you have to move your eyes a bit to the sides, and then the light will be falling onto a region with more rods, which do a much better job of seeing the dark, and so you can see the star better.
So it's the exact opposite of our colourblindness test. The side parts of your eyes might be much worse at seeing colours, but they're much better at seeing faint things. So there you have it, Sean. It's all about understanding the human body's odd little quirks and using them to our advantage. Thanks to Dr. Matt Bothwell for illuminating that question for us as we were a little bit in the dark. Okay, I'll stop now. Join us next week when we tackle this breathtaking question from Greg in Canberra, Australia.
When I exhale, my breath contains carbon atoms. How long ago were they in my food or drink?
What do you think the answer is? You can email Chris at thenakedscientists.com, find us on Facebook, tweet at Naked Scientists, or go to nakedscientists.com/forum to have your say. We hope you enjoyed listening. Until next time.